In this tutorial, I'm going to show you how to install and run a small verilog program as part of our verilog tutorial for beginners. We'll be using a free and open source tool from Icarus, and that should get you a good hang on verilog syntax and other things. So to install Icarus verilog, just search for download Icarus verilog and it should take you to this page, and actually you can go to the downloads. Maybe you could be here. Actually, the best thing would be to go to this my page, which shows their link here, blair.org /iverilog, and this one lists out all the links where I can download it from. You probably need the x64. Just click on it, it will download it, and then double click it, install it. Once you install it, it installs in a directory called iverilog /bin, where most of the binary programs are. And then you need to go to command prompt, which it looks like something like this, and I will go to cd /iverilog /bin, and in this directory, if I already placed a program which I copied it from here. I just copied it and created a new file. Let's see here, C drive /iverilog /bin, a new file called hello.v. I edit with notepad.h. You already know it, but this is the same program. I have it on this website, referencedesigner.com. You can just copy it and paste it in this file. I use a notepad which is very nice. And once you have saved it, you can come out, go to this directory iverilog.bin and give the command iverilog, simple, don't need a exe, hello.v. So if you have everything right, it should generate a file called a.out. And if you make any mistake, for example a syntax mistake like this, I don't put a colon here, maybe here, and make a couple of mistakes, and now if I try to run it, it would give some syntax error. So let's fix those errors and then save it and run it again. We don't have any compiler, and at this point if you give vvp a.out, and it will give the message that we had written here, learning verilog is easy with blah blah blah. So the next thing we could possibly need to know is, okay, one of the things you need to do is you go to your PC and then set up your environment variables, go to its property and then advanced system settings, environment variables, and then in the path you click on edit, and then if you see I already have done this, c:/iverilog.bin. If you have not, you will have to do create a new and then write here c:/iverilog.bin, because if you don't do, then every time you will have to run it from this directory. Your source code will have to be in this directory. If you are able to do this environment system, then you can do this from anywhere from the computer. For example, if I go to another web directory, I call it project underscore cd c:, Okay, and then if I do a directory, you will see a hello.v program here. I can run iverilog from here as well, and the reason I am able to do this because I have set up my environment variable. So you could vvp a.out, and then you should see the same thing on this here. So my next thing would be to write down some real program, and I'm copying and pasting just a simple comparator program. A comparator is a circuit that takes two input and gives one output. If the two inputs are same, it will give an output 1. If the two inputs are different, for example, this is 0, this is 1, it's different, so the output will be 0. 1, 1 is 1 because both the inputs are same. In terms of the circuit, it will look something like this. We are not doing any synthesis here. We are just doing some kind of checking my codes and learning the code. So you can see that if both of them are 0, then 0 and 0 is ANDed here. If both of them are 1, then they are ANDed here and give an output 1. If both are 0, then 0 becomes 1, this 0 becomes become, and 1 1 is ANDed and gives an output 1, and then we OR these two to give these things. In terms of verilog, this is the code that we have, a module comparator. Let's write a small program and call it a comparator or something like that. I'm going to write this program and I save it as let's go to project Vikas and call it comparator, and then I go here and just make sure my syntax is correct. I give the command iverilog data.v. It's not getting any compiler, that means my compilation is good. The next thing we need to do is to check our output, or we do some kind of simulation. We go to the next page of this. What we do is we write a test bench, something like this, and we call it, basically what this test bench does is it sets the input initially at 0 0, and then at time t equal to 20 nanosecond, which is the time scale, I set x to 1 while y still stays at 0, and at time t equal to 20 our output should switch. Initially it should be high because both of the inputs are same, so output should be high. At time t equal to 20 I set x is equal to 1, so my output will change to 0, and then at t equal to 40, which is another 20 seconds, I change my input y to 1, so the output becomes same again, and we get an output equal to 1. So that's how it's a monitor program. You can read more details about it. I will have some other video to tell you the detail about it. Or I have this website that has these details here. Uh, so to compile this, what we need to do is this. These are the two files, comparator.v and stimulus.v. And basically what we compile it is we give a command iverilog -o comparator.vpp and compare it. Basically when we do comparator.vpp, it compares it compiles these two programs. So let's first go ahead and write a new file and paste this code test bench and save as I call it tb.v, and then I give this command. So to run this program, we give this command iverilog -o comparator.vpp comparator.v db.v. So comparator.v and tb.v are the input files, and comparator.vpp is the output file which will be generated if the compilation is successful. If there's no error, it should just give a blank output. And the next thing, to see the output, we need to give a vvp command, vvp, and the name of the file that we have used here, comparator.vpp. If we do this, we see that our input, the outputs, as we have had expected, x equal to 0, y equal to 0, that is equal to 1. When the two inputs are unequal, the output is 0. It becomes again equal when x equal to 1 and y equal to 1, and then so on. So we verify that our comparator is working as expected. So this is a quick overview of how to install iVerilog, run your first Hello World program, verify your environment, and then run a real world Verilog program and verify it on your test bench. I have the links to the tutorial that I used in the below that you can use.